Hey everybody, this is Larry. This is me going over. I'm going to do one more. It's November 12th. I'm going to do a bonus question just because today's problem was a little bit silly. So I'm just going to get a little bit of practice in before the contest, which is in about an hour or so, and then take a little bit of a break, maybe to grab a snack or something. Anyway, today's problem, or today's extra problem for me, is 1038 binary search tree to greater sum tree. What does that mean? You have a BST, you want to create a greater tree such that every key of the original BST is changed to the original key plus the sum of all keys greater than, okay. So you just have to propagate up, right? Because it's a binary search tree, you just sum the numbers to the right and that should be good enough. So, yeah, okay. I mean, I think this is just, recursion, so let's get to it. I think we have to be a little bit careful, of course, but yeah, and I suspect that we have to do something very careful with basically by returning two things, maybe, right? So, okay, so given this node, we want to recurse node.left, node.right, right? Okay. So basically, we want to take up the sum of everything to the right. So, okay, so let's say left sum is equal to this, right sum is equal to this, and of course, if node is none, then we just return 0. Right. Okay, and then now node dot value we add it to the right because those are all the numbers that are bigger, and then we return left plus right plus node dot value before we add this. So we can maybe just do this to subtract it. Maybe something like this. Let's give it a spin. Got that one wrong, so maybe I'm really wrong. Okay, so I return. Did I misunderstand this? So I have 416, and instead I have. Can I thought there was a thing where you can show like a tree, but I feel like. Oh, there we go. Okay, that's actually cool. And in the old interface there is for sure. So okay. Oh. So on the right side I do okay. But on the left side, okay, so I recurse to the left. So then this is 6, right? Why doesn't this add? Wait, did I misunderstand? Oh, I see. I misunderstood the problem a little bit. Okay, let me think about it again. So basically, it's not just on the subtree. It's of all the values to the, like for example, this one. It's all the numbers that are 2, 3, plus 4, plus 6, plus 5, plus 7, plus 8. Okay, so I misunderstood the problem a little bit, but that's okay. That's fixable. All we have to do is change the order, and then now you have the right, and then now you we have to add a thing, but I think that's fine, so that we can recurse it down. So okay, this is also one of those things where I think I'm gonna regret just like mucking around. What I mean is that like I should reset. If you reset, then okay, fine, let's reset it, because I think if by kind of tying myself to what I had before, it might just confuse myself, right? Current sum. So okay, so then now what do? We're going to recurse to the node.right first, and of course on the right side we don't care about the current node, so current doesn't change. And then now current, we want to add it to node.value, right? And of course, node.value, we add it to everything to the right. And then now, so current is basically, yeah, so then now we can recurse node.left current, right? And that's the left side. And then to return the sum, it's just left plus current, maybe, because current is the right and the whatever, right? Yeah, maybe. I don't know that this is right. This feels like I'm missing an edge case, but mostly right, maybe. But we'll see. I might also have to return. Okay, so well, okay, that's a useless case to look. Okay, so this is way wrong because I think I double counted at some point, which is what I was worrying about, because this is okay. Let's think about this a little bit. Oh, this is should be this plus current. Okay, because that's the point of having this current is that you add it, but then now. But then now, okay, let's just maybe do v is equal to no.value, and then now the current we added to v. Oh yeah, something like that. Let's give it a spin and see how it goes. And this is where like I'm only doing it so that I could kind of see how it evolves. And of course this is off by a little bit because this 13 is just, it was longer than before, which is unfortunate. Why is that? So we have 15. Oh, because now this current doesn't include, right, okay. Okay, still a little bit wrong. Basically, this is now 11. Why? Because it's passing in. So current, it passes. What is going on here? So current, it goes to the right. It's 6. And then current. This is this plus right, I suppose. I thought I had this, and then it recurs too much. Yeah. Because this is now double counting an 8. Let me think about this. Wow, this is harder than I expected, to be honest. Okay, so basically what we want current to do, oh, I see, because this also returns this. What we actually want is just also this left sum is now no longer true, in the sense that, okay, let's reset this a little bit. I think this is where I get confused a little bit, because I think I'm trying to return 2 things. I think this is a thing that, and you can probably reason it out, but I think if we just return 2 things, it'll be easier. So okay, if this is none, then return what we want to return. We want to return 2 things. Sum of the nodes, which is our previous code, and then we can also just do it with 2 depth first search. Maybe I try to do too hard with 1 depth first search, to be honest. But yeah, let's do sum of the nodes, and then sum of the nodes. That part is easy. So this is just node dot by v maybe. Left sum, left greatest sum maybe. Right sum, right greatest sum. Yeah. So then this is now left sum plus and then the greatest sum that we pass along. Do we pass that along? What are we returning? We're just returning the number of nodes, right? So we don't care about the current at all, right? Maybe that's the, man, maybe I'm just confusing it. Plus basically right sum plus v, right? Maybe. Oh, whoops. Also this thing, that's why. Whoops. Unknown network error. Alright, there we go. I think I just confused myself with trying to update current and do it at the same time. And now I'm gonna change. I don't like this. I mean, this is probably right, but I want to clean up the code a little bit. I think I try to do too much on the same time, but I think this is now good. Even though I'm a little bit sloppy today. But I think so what I was doing wrong was that I was trying to update current, even though maybe I didn't need to. and then this is just returning the sum, and that's all I need, I think. We'll see. Okay, cool. Yeah, I mean, I think this is a kind of a hard one to kind of make sure. But it's still linear time, linear space, or O of H space is the height of the tree if you want to go that route. But yeah, this is good practice. I mean, I struggled a little bit on this one, so definitely, it's a good problem, good practice on the recursion and kind of figuring out the order of stuff. And in this part, it's about the invariant. I always talk about invariant for these problems, and it holds true for this one, which is that you're trying to figure out, you're trying to figure out all the numbers that are greater than it and hold that value in a place that keeps on going up. And if you have the sum, then that's all you need. But I don't know why I struggled that much with this one. But anyway, that's all I have for this one. Let me know what you think. If you're doing the contest later, good luck. If you're watching it further in the future, I don't know. Let me know what you think. But stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.